Okay, students, this is Mod 2, Topic 1, Lesson 4 now. I've identified in yellow here, follow along with your book, and also have your vocab sheet out. We've talked about base angles before, converse, and remember converse is when you switch the if and the then. Hypothesis is after the if, conclusions after the then. The conditional statement is an if-then statement. Biconditional is when you say if and only if. So it's true in both directions is what that means. Exterior angle theorem, we've talked about it, but we're going to get into that. Remote interior angles, that deals with your exterior angle theorem. Mid segments, okay. We'll talk about that. So if we look over here at our goals, we're going to talk about exterior angle theorem, mid segments of a triangle. We're going to talk about the triangle inequality theorem, which they're calling triangle side length inequalities, just triangle inequality theorem, and again, the mid segments of a triangle. Okay, so first off, you can pause the video, do numbers 1 and 2 on your own, compare it with your neighbor, and then hit play again after you've done that. 247. What page is this right here? 249. Okay. All right. Isosceles triangle, the congruent sides. Let's just draw one out here. I've already talked about this in class, but it's coming up here again. So here we're in an isosceles triangle. Remember the definition of isosceles triangle is at least 2 congruent sides. The congruent sides of an isosceles triangle are called legs. So those are the legs, as it says right here. And this is called the base. Okay, and this is called the vertex. So the vertex is always opposite the base. It does not have to be vertical. It could be over here horizontally. And then there's the base. And there's the vertex. Okay, so the vertex is where the angle where the 2 congruent sides come together. The base is opposite of the vertex. So it doesn't have to be a vertical isosceles, it could be a horizontal isosceles triangle. Okay, and then these are called the base angles. Obviously it's on the base, so it makes sense that those are base angles. Okay, and we know base angles are congruent. The isosceles triangle theorem says if I have an isosceles triangle, then base angles are congruent. And then remember the converse of that would say if base angles are congruent in a triangle, then the sides opposite them are congruent, which makes it an isosceles triangle. That's the converse. Okay, so here we talk about that again. Hypothesis is the part after the if, the conclusion after the then. The converse is when you switch. And let's call it interchange. Just switch the if and the then. And the whole if-then statement is called a conditional statement. We've already talked about that. So the conditional statement of 2 sides of a triangle are congruent, and the base angles opposite the congruent sides are always congruent. That's the isosceles triangle theorem. That's what that says. And so this is the converse of the isosceles triangle theorem. Okay. Those are always, one or the other is always on the DCAS. I told you there's always at least 2 problems dealing with isosceles triangles on the DCAS, so it's popular. That's why we went over all those characteristics of it. All right, so here's where we talk about biconditional. It's a statement written in the form if and only if P, then Q. It's a combination of both the conditional statement and the converse. It makes them both true. Okay. So if both directions are true, then we can write it as a biconditional statement. And how you write it as a biconditional statement, you don't write if to begin with, you just write the hypothesis, and then in between the hypothesis and the conclusion, you write if and only if. Okay, is how it's written. You're not going to have it on your assignment, but that's what it is. Okay. Triangle sum theorem. That just means that we know all triangles, the interior angles of a triangle add up to 180 degrees. That's the triangle sum theorem. Exterior angles, okay, we're going to get into that here. We're not going to deal with that here. Remember, this is how we, yesterday in your class, yesterday you did your equilateral triangle. Remember, we just have a segment, open up more than halfway. Well, actually, if you want to equilateral, you have to go to the other piece. So from R, put the pointer on R, pencil on S, draw your semicircle. You don't have to draw the full circle, turn around, draw the other semicircle. And then where they intersect, connect them to the endpoints. And now you have an equilateral triangle. And remember this, what you just created was a perpendicular bisector. That's the, remember from the perpendicular bisector theorem, that every point on that line is equidistant from the endpoints. But that's how you create an equilateral triangle. Instead of just open it more than halfway, I open it up from the one point, put the pencil on the other point, and draw my semicircle and then turn around. And that creates an equilateral triangle. We're not going to do that there. Let's see. Oh, okay. So exterior angle and remote interior angles. Okay, so if we have this right here, this is the exterior angle. If I extend out one of the sides, doesn't matter which one, that's extended, that's called the exterior angle. Exterior meaning outside. And remember, that equals, so the measure of angle S equals the measure of angle T plus the measure of angle TRS, or I could say TRQ. Okay, so this angle and this angle are called the remote interior angles. And remember, I told you another name that they sometimes would call it is opposite interior angles. Okay, so if it's not already on your vocab sheet, you want to draw it out, draw out the picture. I think it's on your DCAS sheet I gave you. Okay, but otherwise put this on your vocab sheet. Exterior angle, right there, equals the sum of the two remote. So the remote or opposite interior are the two angles that are not adjacent to that exterior angle. Remember, this one would be the adjacent angle because it's next to it. So there are two remote or two opposite interior angles are the other two that are not adjacent to that exterior angle. That's the easy way to remember it. And so I add those two remote interior angles, are also called opposite interior angles. It equals that exterior angle. You're going to be practicing that today on your assignment. That's why I spent extra time right there going over that. Okay, so here's an example that is extended out. So this could be an exterior angle right here. That would equal angle 1 plus angle 2. Or this one also. If I extend that out, this is an exterior angle. Of course, that makes sense because these are vertical angles. So we know those are congruent. Okay, would equal angles 1 plus 2. And you could do that for any of the sides right there. Okay, so that's the exterior angle theorem. Okay, triangle inequality in midsegments now. Okay, now you know, remember from watching the circles video that you should know that this right here, it's called a secant because it goes through the circle twice. It's twice on it. Okay, this is also a secant right here. Goes through twice on the circle. So you have two secants on that, just reviewing vocabulary. Whereas that is a radius, going from the center circle to the outside is a radius, a little r for radius. Okay. The triangle inequality. Here we go right now. The sum of the lengths of two sides of a triangle, it's always you just take the smaller two. Just take the smaller two, then you only have to do it one time. Smallest two. Okay, so you want to write, it's got to be greater than the length of the third side or the longest side. The two smallest have to add up to greater, not equal to. That's going to be a trick question to see if they'll have one that's equal to. It's got to be greater than. So make sure you write this in your vocab formula sheet right here. Triangle inequality theorem says if I add the two smallest, it is, technically it says any two sides are greater than the third side. Okay. But if you only want to have to do it one time, you just take the two smallest sides. It's got to be greater than the third side. Then it will form a triangle. If it's not greater than, if it's equal to or less than, then it will not form a triangle. Okay, so make sure that's added to your notes. You can do that for a homework assignment. Okay, mid-segment now. Last piece that's also on your assignment. The mid-segment of a polygon is a line segment. Obviously, it's got the word segment in it, so it's a line segment that connects two midpoints of the sides of the polygon. Okay, so let's see if they have a drawing of it over here. Otherwise, I'll just draw it myself. Okay, guess not. So, there's a conjecture and a theorem. Remember, theorem is proved, and a conjecture just appears to be true, but it's not proven yet. We already talked about that. Okay, so let me go ahead and draw a mid-segment and draw an example of the mid-segment theorem to help you on your assignment. Okay, so that's a mid-segment because it is the midpoint over there. That's a mid-segment because it's the midpoint of that side. There's two characteristics when I have a mid-segment, okay? And you can have a mid-segment of a trapezoid as well. Okay, we'll do it. A trapezoid as well, but on your worksheet today, it'll just be with triangles, just so you know. Okay. Two characteristics when I have a mid-segment. So I'm looking for the mid-segment is parallel to the base. So that is parallel to that and is 1/2 of the base. Write this down in your vocab sheet. I don't care if you put it on here or not, but put it on your vocab sheet. I believe it's also on the DCAS already. Okay, so now let's say this is 10. Then that's half of the base. So the base got to be 20. Double it. So I can't remember if I gave you simple ones like that. Remember on the DCAS, I'll never have just numbers. It's going to have algebraic expressions. So that's what I have on your worksheets. So let's say this says x plus 2, and this says 2x plus 4. So what I'm going to do is I'm going to double, every time I'm going to double that mid-segment. 2 times the mid-segment equals the base, 2x plus 4. So I get 2x plus 4 equals 2x plus 4, and I get 0 equals 0. So that means any number will work. Okay, when I get the same thing on both sides, 0 equals 0, that's always true. So any number will work. I plug in a 1, I get 3. I plug in a 1 down there, I get 6, 3 to 6. So I plug in a 2, I get 4. I plug in a 2 here, I get 8. I plug in a 3, I get 5. I plug in a 3 there, I get 10. 5 to 10. It's always half. Okay, so that's an exception to the rule. Usually you're going to get an answer, x equals some number. So that, just so you know, on a side note, even though you're not doing it on this worksheet with trapezoids, same rule applies. So that means this is parallel to the two. Instead of one base, you only have one base in a isosceles triangle. You have two bases in the trapezoid. So that mid-segment is parallel to both bases. Okay, so still that parallel to the base. You could put in there base is if you're talking about trapezoid. Okay, and it's equal to half of the two bases combined for this one because you got two bases. Okay, so let's say this is 10 and this is 4. Okay, well, if I go ahead and double that mid-segment, just like we did 4, 2 times 10 has to equal 4 plus, we're just calling that x. So 20 equals 4 plus x, so x would equal 16. So notice if I add the two bases together, 16 plus 4 is 20. I take half of that and I get that length of that mid-segment, 10. So the same rule applies with trapezoids. You're not doing that on your worksheet today, but just so you know, you can have a midsegment of a triangle or of a trapezoid. Okay, and same rules apply. So if you think of this, this base is 0, it's just a point, whereas this base is a length of 4. So obviously I take the one base they have here with the vertex, which that base, if you want to call the vertex base, is 0. There's nothing, no distance there. So anything plus 0 is still itself. Okay, so the same rules would apply. All right, that covers everything you need to know. Let's see, did I want to have you do any of these at all? 257, let me see. Yeah. Okay, so that's what's on your worksheet, those right there. Draw an example of each conjecture made in this lesson, the basic of these triangles. That's just saying to draw these. You can draw those out. And same on this right here. Draw it out just to show it. So you just drawn it out yourself instead of just watching me draw it out. That's all it's saying right there. That should all be basic. Okay, down to there. All right, so that ends that. You'll get a worksheet now on that triangle inequality. The sum of the two smallest have to be greater than a third. That midsegment theorem, the midsegment is parallel to the base and is equal to half of the base. And so you just double that midsegment, set equal to the base, and solve. And then exterior angle theorem equals the sum of the two remote interior angles, also called opposite interior angles. All right, that'll do it.